Hi, in this video we are going to see what is land cover classification and how we can do it in Google Earth Engine for Sentinel-2 data. First we will see what is land cover classification. So land cover classification involves the categorizing the Earth surface into different classes based on the physical characteristics and the features present. So these features include like forest, grassland, water body, urban, agriculture fields, and desert, wetlands. So like that. So if it's a land is it will be there means like we are categorizing into like different features, like different land cover classes based on like our needs and our management requirements. So that is land cover classification. In land cover classification, there will be two types of classification. It will be there. One is unsupervised classification. Another one is supervised classification. Unsupervised classification is the cluster based classification. We won't give any training data to the unsupervised classification. Automatically it will be categorized into different types of cluster 1, cluster 2, cluster 10, like that. So how many number of cluster we need, it will give. So after getting a cluster, we will assign into one land features. These two clusters based on like urban area. This two one cluster is based on like land areas. These clusters are for agriculture area, like that. That type of classification, it's called unsupervised classification. Another one classification is supervisor classification. Supervisor classification means initial stage itself we will give the training data, already predefined data. These places are for agriculture area, this kind of places are for urban area. Like that we will create some based on polygons or point, we will give the training data. Then we apply the traditional supervisor algorithm or machine learning algorithms. So after that it will give the results based on our training areas. That classification called supervisor classification. So in this video we are going to see supervisor classification only. In the supervisor classification also in GE we are going to see for machine learning classification. In supervisor classification, initially first step it will be creating training data. So maybe we can, based on visual interpretation, we can define the training areas in the satellite images. Otherwise, if you went for a survey, you are collecting for ground data, based on that also we can create training data based on ground data. In that data, for example, if it is a urban area, it will be there means based on visual interpretation, we can create one polygon or points. We will tell them these pixels are belongs to urban pixels, then these pixels are belongs to water pixels, these pixels are belongs to for agriculture pixels. Like that we will create like some certain number of polygons or point as a training data. Then based on the training data it will create the signatures. Then we will apply the machine learning algorithm. That algorithm will classify the whole images into different land cover classes. Such as if you given training for like three classes for urban, water and agriculture, means it will give the it will classify the image into three classes. If you give for five classes, it will classify the images into five classes. Then finally we will evaluate our results, classification results, how much accuracy we got the images, like that. So for in this video we are going to apply for machine learning algorithms. Machine learning algorithms little bit different from for a traditional method of land use land cover classification algorithms. So for in traditionally we will use for maximum likelihood minimum distance kind of algorithm. It will based on the statistical analysis. It will give the results, statistical analysis, and based on input data it will give the results. But in machine learning algorithms also we will give for training data as input data. But machine learning algorithm it will use the mathematical models and the patterns learned from labeled training data, and it will classify as a image. Actually, machine learning algorithms it will handle the complex relationships and patterns in the data. It will require less number of training data. So these algorithms do not require for explicit for user defined like more number of training areas. Then one more like important advantage of machine learning algorithm is it machine learning techniques too, it automatically learn the patterns and relationship in the spatial data. So this is the like main advantage of machine learning algorithms. So in Google Earth Engine there will be like four machine learning algorithms available in build. So one is for cart algorithm. It's a classification and a regression tree algorithm. e.classifier.smile is a syntax for to apply that algorithm. Another one algorithm for naive base, then support vector machine, and the final one is for random forest. For each algorithm, it has a own procedure and own way of working. And this below are like these are like earth engine syntax. e.classifier.smile naive base e.classifier.lib svm like that. We will see it in that demo class. So in this four type of classification algorithm, we are going to see random forest algorithm. So random forest classification algorithm are widely used algorithm for in the classification purpose. It is based on like tree based machine learning algorithm. It will use for a series of decision trees to select the best classification for all pixels within that imagery. So for in that initially we will define like number of trees we are going to apply for this algorithm. So initially suppose we will give for training data, we will select some areas are for urban areas, some place for vegetation and water pixel like that we will give the training data. So in that based on the training data, the random forest classification algorithm it will get trained. Then if you give for like four number of trees means it will create the tree based rules. Algorithm itself it will create the tree based rules. For if you define for four number of four trees means like one tree it will give for that for while predicting the results, one tree it will give for urban, another tree it will give result as a background, another tree it will give for urban means. So in total in another tree also it will give the result for urban means most number of trees, like most number of based on decision rules it will give urban means like that it will give us a end result. So based on that only it will, in this algorithm will work. So for more number of detailed explanation, please read the full documentation of like Google Earth Engine random forest algorithm one. Then we will comes under for error matrix after we got the after we classified in the land cover classes, after we got the results, we need to evaluate our algorithm and we have evaluated our results, how much accuracy we got it like that. So for that purpose, so while giving the training data to the algorithm, suppose for 100 points or 100 polygons you are giving training to algorithm means in that. So usually what we will do it means like 80% of data for 80 polygons we will use it for training purpose. Other 20 polygons or 20 points we will use it for test purpose. In that 20 polygons, like how many areas it correctly calculated or how many polygons it wrongly classified. Based on that we will define the accuracy that's called for error matrix or confusion matrix. The diagonal values are like correctly classified pixels are places. Based on that we will calculate for overall accuracy for number of correctly classified pixels and for number of total sample pixels like that. So this part also we will see it in our Google Earth Engine itself, we can calculate it. So accuracy assessment for is important for like any land use land curve analysis or any all the remote sensing analysis. Always we need to tell our model how much it will be accurate like that. Suppose that accuracy it is a less only we got it, we didn't get for us best like good accuracy means we need to again we need to train the data with new trainings. So then only we can improve the accuracy. So now we will see this analysis how we can do it in Google Earth Engine. Again we will come to Google Earth Engine code editor. So so in this what we are going to see means like how we can do that supervised random forest classification in code editor. So first like variable ROI already we have created that one for it is our region of interest and that boundary is a file. So next we have for function of marks to clouds. So this one we will get it from that Google Earth Engine Sentinel-2 code editor one. After that like after that we imported Sentinel-2 images for Sentinel-2 images image into code editor. Then we filtered based on the region of interest and for based on date and cloud pixel percentage, and we created for a median of that images. Then I have extra I have added one line of code that I only selected the bands necessary, like that 13 bands of Sentinel-2 alone. So if you didn't use this line of code, means like it will give for all unnecessary some extra 23 bands, that kind of things, that no need for our analysis. So then I am printed the data sets. So if I click run button, it will get printed the total number of bands. In that bands list also only like necessary important, that all bands only it will get listed. So in map dot center object means like whenever we are running this program, it automatically it will locate our region of interest on our study area. Then here I have created one variable called visualization. So that in the visualization I have created for band 4 3, like only I have visualized the important these three bands, and I added into map. So this is our true color images. You can see it for it's a in three bands RGB channel, it will be there, like in red channel, band 4 we are visualizing. For green channel we are visualizing band 3. For in blue channel we are visualizing band 2. So using the true color image itself also, we can able to create the training set, training data. So which places are for agriculture, and which places are for building, and which place for water and forest, like that we can able to identify. But sometime for GS analyst, for good GS analyst and remote sensing persons will use for false color composite images. Why they are using false color composite images means, in false color composite images, that agriculture vegetation area, it will be like more visible, and we can able to differentiate with the other features very easily. So what is false color composite images means, in true color in left side panel we are seeing for this a true color image. In true color image we will use for band 4 3 2 in the respective channel of for red green in blue colors. But in false color composite images we will use near infrared band in the red channel, and band 4 for in green channel, and band 3 for in blue channel. So whenever we are using for near infrared, in near infrared band values are like more in for that vegetation for in the agriculture areas. So that vegetation it will be like more visible. Here you can see the difference between the two images. The two images here in right color image are in false color composite images. For agriculture and for vegetation and forest areas are more visible, and that water area it will be in the black color. So here we can differentiate each and every feature very clearly compared to for true color composite images. So this is for this is the difference between like true color image and false color composite images. Here you can say for band 4 they are visualized in the red color, band 3 in green, and band 2 in blue. So combinedly they have one image it will come, that is a true color image. But here it is opposite, like not opposite, but it is a different. Band 8, their band 8 near infrared band they are visualizing through the red channel, and for red channel red band through the green channel, and green band that one through the blue channel. So likewise there we are creating false color composite images. In that false color composite you can see that agriculture areas, that vegetation area it will in the red color, so it is easily visible. So in first step what we are going to do, it means like what are the classes. So I will change into false color composite images. Like here itself we can change it. So band 8, band 4, band 3. So after this what we have to do, it means we need to create the training data sets. So using the training data set only we will we can train the model, and we can get the land cover classification. We can run the model and we can get the land cover classification. So for to train the data, for to train the model, so we need to create the training features using point data or polygons. So I will prefer for polygon data. Why polygon means, if you create one polygon means that polygon will cover many number of pixels. So so model it will get trained like more efficiently. So to create for training data, first create in the in layer panel we have click new layer. After creating new layer, automatically default name it will be the geometry. Click that one, and here you have to select that rectangular or in this polygon one try shape. I selected for this rectangle. So first we will create for forest. So these dark regions, these hills are like mostly that forest areas. So I am creating forest for many polygons. So here 4 5 polygons. You can for reference you can also use it for like satellite image also you can use it for the reference. So the bottom side it will be the satellite images and the top side the images only for our satellite Sentinel 2 images. So I created for 12 polygons. After getting 12 polygons, for better results, so for each features at least we need to create training data sets for like 20 to 30 based on areas. If it's small area for 13 polygons, it will be enough for each different features. If it's a bigger area, we need to train more number of polygons. So once we after creating that polygons, I changing that geometry name into forest. Then property I'm changing to land cover and I'm giving value to 1. So here I will change to like some dark green color. Here you will get the color code. So in this color code we can use it for our visualization. After classifying the images we can use it for our visualization. I click OK. Now we created for one feature the forest. Then we can unclick and we can now we can get for another new layer. In that layer we can we can create the we can digitize the water areas. Here you can see the black color pixels. So these all are for water areas. You can zoom it. So always remember that base map it will be latest one only it will be there that behind the base maps. So these are base maps it is for latest images but what we are using for 2020 satellite images under that. So always you need to interpret the image based on our satellite images. Base map it will give some overall idea only. So we need to use for visual interpretation techniques. If it's a black color, then only it means it has the waters. Not in nearby areas, it won't be the waters. So now I created for waters. Same like I am changing name into water. Instead of geometry, we have to select for feature collections. Then property, I'm giving name for land cover. Then value, I'm going to for initially we created for forest that will be the name 1. For land cover values we given the 1. So for this feature I'm giving value say 2. Then color also I'm selecting for some blue color. So now we have created 2. So next we can digitize the agriculture areas. So agriculture areas you can easily find out this like a rectangle shaped fields. So in this some of the areas are like fallow land but now we consider say fallow and for agriculture are both and same classes. So now I have created some one for agriculture same feature collection agriculture property land cover is values 3 some light green color will take it. So then for these are like barren lands you can see for in barren land it will be there some white color batches it will be there. So these are like everything it's a barren land. Same like you can create a new layer and digitize the barren land also for at least for each for example purpose I only digit for 10 12. So after that I will create like more number of features. Digitize barren land also create like a new layer and digitize it and name it for as a barren and give the value for 4. Then for next for urban build up areas for here In the satellite base map you can see these are built up areas. Here on built up settlements are there. So in my study area, here it will be the settlements it will be there. So again create another layer and digitize for small polygons, name it as a build up and give the value as a 5. The forest area and yeah, as a feature I select as a feature collection, then property I given the name of land cover and given the value for 1, same like for water value 2, agriculture is value 3, and the barren is value 4, and the build up is like value 5. Here you can see that for each features I created for more number of polygons. I have digitized it. Then next what you have to do it means, so I will uncomment all the images. I will. So I have digitized for a different feature for a number of polygons. So next we need to combine all this data into like one single data. So I have created for variable training data as a one variable name. In that variable name I am merging for forest dot merge and water and dot merge dot agriculture and merging at barren land and dot merge dot build ups. Like that I have merged as a only as a training data alone. So if I call to training data means it will give for all the data, it will I will get it. So I will run this program. After merging the data, we need to divide this data into two parts. So for this purpose, first I have created a variable sample sample variable name. In that name, like I changed this training data and I say on a randomizer column. So what it will give means for all the training data, it will give us some one random numbers from starting from 0.012 for 1.004, like this. It will till that like it will give for some random numbers. Based on that, I am separating the dataset into two types of dataset: variable training sample and variable validation sample. So in what are the polygons has the values for less than 0.80 and equal to 0.80 means like more than 80% of data it will consider as a it will get stored as a training sample. Remaining for 20% of data it will store under like validation sample, like that. After we divide into for training sample and validation sample. So, so, so like after that like we are converting into a, like our training data sets. So here variable training means I am just on that 80% of data sets I'm considering say I'm going to use for a training purpose. So for that I am selected data set dot sample regions. In data set means that a satellite image name is for data sets. Here data set and sample region training sample I am considering it as a for a training purpose. Then it will take as a land cover classes. Then I am mentioning for scale for 20. We can mention for 20 or 10, like based on purpose we can mention. Then I have created another data set for validation purpose. Same say satellite image we are going to use for same satellite images only, but in the collection we are using for validation sample. So here you can see it for I printed out the training data. Here you can see for the list of all the 134 elements it will get printed. So all the 134 elements it will be the training data. So we converted all the all features into one single features for our training and our validation purpose. The next line what I am next line what we did it what I did it means like variable I created for random forest classifier 1. Then e dot classifier smile random forest is a syntax for a random forest algorithm. In the train we are using. Then for a training I use for that training data sets. Here we already created for a variable training using for training sample, so that one I use for our training the data sets. Then based on that I get I we classified the that satellite images, and that satellite image get stored as a in classified variable. So here I added that classified variable name into the maps. Then for palettes I have added for like that for each land cover I am going for the separate colors. For forest I am going for green and water blue. For agriculture barren build-ups based on here the color codes I have added here. So that that layer will add get in the name of classified map as a classified map. It will get added here in the layer panels. Then after that we did it for like accuracy assessment. For accuracy assessment we are going to use for validation, that validation sample. So that training sample we initially separated as two parts, for 80% for training data purpose, then 20% for validation purpose. That 20% of data only now here we are using for getting the accuracy assessment. So in the validation you can see for here validation, in the validation is a classify RF classifier. We already created the random forest classifier, and that name here we added. Then we are we did it for we added the for the that confusion matrix, that is syntax. Then I added to printing the that validation accuracy. Then for that overall accuracy of that confusion matrix data. Here next table it will next line it will be the I am just used for random forest classifier explain code. It will give the total number of random forest trees under their important variables, under that are the variable importance everything. So here I separately I printed out the variable importance. So now we did the random forest algorithm. In the random forest algorithm, which variables are used for like most like topmost features, which features are used for that one, which likewise like we can do it for variable importance also. So that one it will give the variable importance. Then that variable importance I have added a chart. As a chart I added into the map. Now we will run this program. Now we got the all the results. So the training feature it will give the for a whole training data, like totally we have created 134 polygons. In that 134 polygons 107 polygons, 107 elements is taken as a training samples for 80%. In that 27 elements that we used for the validation one. Here it is created for validation error matrix, that confusion matrix. We got the confusion matrix. Then overall accuracy of our model it will be for 0.93. For 93% we got our overall accuracy. Then this one it will be the random forest algorithm details for number of trees for each trees, how it calculated in that one. Then for in features we got it for like variable important feature for in total tool bands, which bands are like mostly useful for in this for land cover classification. For that purpose here you can see that we also added the as a chart for variable importance. In that for band 1 perform the performed over in the top. So next for band 11, band 4 and band 9 like mostly useful for to create this land cover. So here we can zoom it for our region of interest. So this base map is for like our Sentinel-2 images in the false color composite. In top layer it will be the for classified map. So our map get classified as like 5 different features. We can give for these are forest area, and mostly this place are for agriculture area. Here for barren lands, and then the red colors are for built-up areas. That blue color we can, if you zoom out, we know. So these are like for water areas like that. So here this place also for building only wrongly classified as a barren land. For the purpose, like again we need to train the sample. In the training sample we need to add this building as a own building like that. So based on if you get like low number of accuracy and you didn't get good accuracy means we need to train the model as a like with like good features. Thank you.